In this video, we're talking about finding a sample size needed for a set margin of error. Before I jump into this specific example and show you how it's done, let's just talk about why do these problems exist. So when we're creating our confidence intervals, yes, we're trying to pin down a population, either mean or a population proportion, right? When we create an interval, let's say we're dealing with proportions, and you create an interval and you're saying, I believe the population proportions is somewhere between, I have 95% confidence that it's from 20% to 80%. That is a massive, massive interval. So you're trying to pin down a population proportion and you're telling me it's somewhere between 0.2 and 0.8. That is a massive, massive range that our population proportion could be in. So if you're going to give me such a big range, it's pretty much useless information to me, right? It'd be the same thing as, if you're in class, someone's saying, hey, the class average was somewhere between a 40% and 100%. You're probably like, great, that tells me nothing. So where this comes into play is before statisticians actually go out and collect their samples, they say, you know what, I want my confidence interval to be useful to me. So they figure out what type of sample size is needed to determine how big they want their interval, because the margin of error is going to control how wide or how skinny that interval is. So they kind of go out beforehand and say, you know what, I'm kind of acceptable with an interval that, is basically 6 percentage points wide or something like that. That's what's happening here. So this work is done before everything, and then people would actually go out and collect their samples and then get their confidence intervals. Okay, so let's look at an example here. I have some AP Stats students are trying to find the proportion of students who buy lunch at their school. Before they create their confidence interval, there's a few things they want. They want their interval to have a margin of error no bigger than 3%, and they want 90% confidence. How big of a sample size do they need? So when you're looking at this problem, the first thing I think about is we're dealing with proportions here. Okay, we're dealing with proportions because they want to figure out the proportion of students who buy the lunch at their school. So we're dealing with the one proportion confidence interval. Now they're focusing on the margin of error, which remember the back piece here after the plus or minus, that whole bracket there in red, that is my margin of error. Okay, so our focus for this problem is going to be entirely on this back piece. So I'm going to plug in some information that I have up above into this formula. So I know I want this to be no bigger than 3%, and they want 90% confidence. So the 90% confidence is going to be the Z piece, okay? Z star. Because it's 90% confidence, I know Z should be, 1.645, okay? The margin of error, I know this entire bracket should be less than or equal to 0.03. So you might be wondering, let me flip it around. I have a better written down example here. The margin of error should be 0.03. Now you might be wondering, well, where did this 0.5 come for the P hat and the Q hat? If you know a P hat already, you use that. So maybe the problem says, you know what, we believe our sample is going to be around or a proportion of 0.6, then maybe we use that. If you don't know a P hat going into this, what we're going to use is we're going to use 0.5 in its place. So if you know P hat and they tell you to use a prior used P hat, you use it. If you don't have a P hat to work with, use 0.5. So 1.645 came from my 90% confidence. 0.5 came from I don't know P hat, so I use 0.5. And this is all going to be less than or equal to 0.03 because that's the margin of error. We want it no bigger than 3%. So I took that 3% and I changed it to proportion because everything else is in terms of proportion. After that, it's just a pretty straightforward algebra problem of trying to solve this inequality for n. So the first thing I did is I split the top and bottom of my square root there. The top is the square root of 5 times 5. The bottom is the square root of n. I went ahead and multiplied this entire top out to get 0.8225, left the right side alone. Next thing I did is I needed to get rid of this square root of n on the bottom of my fraction. So I multiplied the top by the square root of n, and I multiplied the right side by the square root of n, multiplied both sides. What happens here is when I have a square root of n on top and the bottom of the fraction, these are going to cancel out, okay? So I'm left with a 0.8225 is less than or equal to 0.03 times the square root of n. Trying to get n by itself, so I move the 0.03 to the other side by division. And then finally, to get rid of the square root with the n is I square both sides. So I get it all down to 751.67 is less than or equal to n. I know I went a little bit quick through this algebra here, but being that this is for an AP Stats class, the math shouldn't be too difficult. There's other ways you could go about solving this in the order and how you want to organize it. Do whatever you want to do, just make sure you solve this inequality for n. So what we get is we get this result here, which says 751.67 is less than or equal to n. What that means is I need a sample size that is at least 751.67. So really I'm going to need a sample that is no smaller than 752. If I get a sample size that is 752, and I can go bigger than that if I want, I'm going to end up with a margin of error that is no bigger than 3%, which that is what they want in the original onset there. Okay, so again, quick overcap here. You're looking at the back end here, the margin of error. Set it less than or equal to whatever margin of error they want, and then you're off to solving the error. Use a 0.5 for p hat if you don't know it. If you have information that they want you to use for p hat already, use that. And that was finding a sample sizes needed for a set margin of error.